All right, so as we saw in the first three problems, we computed the limit definition of a derivative. We used the limit definition of a derivative to get the derivative of a function. We found how to, problem two, we saw how to find the slope of the tangent line. And now in problem three, we use these practice basic derivative rules. So what I want to show you in these next three examples, problems 4, 5, and 6, is how to write out the equation of your tangent line, given some function and you're given some value of x. So when you're given those two conditions, to solve this problem, it's done in 4 steps. First step is find the derivative of your function, find the slope of your tangent line, find y1 equals f of a. Again, you're only given the x coordinate of a point, so the y1 is the associated or accompanying value, to complete the ordered pair essentially for the given value of x. And then step 4, you find the equation of your tangent line, where you can write it out in point slope form and then convert it to slope intercept form. So let's look at this example. Here we have f of x equals negative 2x, negative 2 cosine of x plus 5 at x equals pi. So first thing is you want your derivative of your function, f prime of x. So as we established in the previous video, what is the derivative of cosine? Negative sine of x. Now, if the derivative of cosine of x is negative sine, and I have a negative 2 coming along for the ride, what happens to the two negatives? Positive. So f prime of x is going to be a positive value, or a positive, it's going to be a positive 2 sine of x. Now, what is the derivative of 5? It's a constant, so the derivative is 0. Thank you. Derivative of 5 is going to be 0, so I don't need it. So that's step 1. Step 2 is where you find your slope of your tangent line. We say m tangent is going to equal to f prime evaluated at the given value of x, which was pi. So f prime of pi is equal to 2 times sine of pi. Now, do anybody remember what's sine of pi? It's 0. Sine of pi is 0 because if you think of back to your unit circle real quickly, let's say I draw a circle here. Here's the location of pi, and it has the associated coordinates -1, 0. So by the unit circle definition, we say that sine of any angle is always equal to the y coordinate, and cosine of any angle is equal to the x coordinate. So since you're at pi is associated to -1, 0, sine of pi is 0. Yeah, I think it's drizzling. It might be raining though. So we get 2 times 0, which is 0. So look at our slope of our tangent line. The slope of our tangent line is 0, which implies that we have a horizontal tangent line. Okay. Now what I need to do is find y1. So y1 is equal to the original function evaluated at pi. So this is -2 times cosine of pi plus 5. Well, look at your unit circle. What is cosine of pi going to be? -1. So if cosine of pi is -1, then this is now -2 times -1 plus 5. Now, what's -2 times -1? 2. So 2 plus 5, 7. All right, let's write out our equation of our tangent line. What we're going to have is, in point slope form, y minus y1 equals to m tan times x minus x1. So the y1 value is 7, m tan is 0, x minus x1, which is pi. Now, good things happen for us here. What happens when I take 0 times x minus pi? It's 0. So that whole right-hand side of the equation is 0. So it's y minus 7 equals 0. And if you want to write this in slope-intercept form, it's just y equals 7. What you essentially have here is a horizontal tangent line. But if you notice, with this problem, that was the 4 steps being done. Any questions? All right. Wait, yeah, got a question? Good.
That's negative 2 cosine of the original function, right?
Yeah, so you're looking at y1 equals f of pi. That means you're evaluating the original function at pi to get the y coordinate. You see, they only give you the x coordinate. The x coordinate was pi. That was, we were happy they gave us the x coordinate, but we would have been even happier if they gave us the y coordinate. They didn't, so we had to find it. Maybe on MyLab you don't have to do that step. Maybe that step is already done for you, but you still have to do it. Okay. All right, ready for the next example? Okay, let's look at problem 5. So in problem 5, it says that we want to find the equation of the tangent line to the graph of the function f of x equals negative 4 e to the x plus 7 at x equals 0. So again, first step here is that you want to find your derivative. So we said in the previous video, that the derivative of e to the x is what? What is the derivative of e to the x? Itself. So the derivative of negative 4 e to the x is just simply negative 4 e to the x. What is the derivative of 7? 0. Do I need to write plus 0? No. So our derivative, f prime of x is negative 4 e to the x. Now you find your slope of your tangent line by evaluating the derivative at x equals 0. So it's negative 4 e to the 0 power. What is e to the 0? 1. So it's negative 4 times 1, which is negative 4. Good. Now what we have to do is find our y1 value, because again, we only were given the x value. So y1 is equal to f of 0. So this is negative 4 e to the 0 power plus 7. Well, we already showed that negative 4 e to the 0 is negative 4. So this is just simply negative 4 plus 7. That is 3. Very good. Now we use our M10, the y1 value, and of course our value of x to write the equation of the tangent line in point slope form, and then convert it to slope intercept form. So it's y minus y1 equals M10 times x minus x1. So it's y minus y1's value, which is 3. M10 I know is negative 4. X minus x1's value is 0. Okay, so here's your point slope form. Let's convert it to slope intercept form. If I convert this to slope intercept form, y minus 3 is equal to negative 4x, right? Distribute the negative 4. Negative 4 times negative 0 is just what? 0. Then you add 3 to both sides. And you say your answer is y equals. There you go. Any questions? I can zoom in a bit just in case if you didn't see it. But how simple is using the derivative rules now to get your slope of a tangent? It's easier as long, but the thing is, just remember, guys, you have to practice the limit definition of the derivative because they'll ask it on the final. Don't use the limit definition of the derivative. You get no credit for that problem. All right. Ready for the next example? Okay, let's look at problem 6. So problem 6 states, find the equation of the tangent line to the graph of the function f of x equals 8 plus 5 ln of x at x equals 1. So first thing is, you want to find your, oh, there we go. First thing is, you want to find your derivative. So if I want to find my derivative, well, let's start with 8. What's the derivative of 8? 0. Right, so I'm just going to put the 0 there, just for now. Now, what is the derivative of ln of x? We talked about this earlier in the previous video, so you just have to look back into your notes. 1 over x. Well, I'm going to stop you there. ln of x is 1 over x. But since I have a 5 in front of it, it'll be 5 times 1 over x. But when you clean up your derivative, 0 goes away. You do 5 times 1, which is 5, divided by x. Okay. So now we proceed to the next step. The next step, what do you have to find? After you have your derivative? M10. You find the slope of your tangent line, which is M10. So M10 is equal to f prime of 1, since x was equal to 1 in this example. So it's 5 over x, or 5 over 1, which is 5. All right, M10 is 5. Now you proceed to the next step. You have to find the y coordinate. Y1 is equal to the function evaluated at x equals 1. So it's 8 plus 5 times ln of 1. Now, do anybody remember what's ln of 1 from pre-calculus? It is. Very good. It is 0. Right? So quickly I can show you this. So if you look at a graph, essentially you have that ln of x, in short, ln of x and e to the x are inverse of each other. And therefore they reflect along a line called y equals x. So if I drew the graph for, let's say, e to the x, it's always above the x-axis. It's never negative. So, sorry, this is a bad graph. But that point there is going to be 0, 1. Now, ln of x, right, y equals ln of x here. Oh, sorry, y equals e to the x. If we reflect this graph along that line, y equals x, your identity function, then the ln of x will be basically in quadrants 1 and 4. It starts somewhere in the bottom of quadrant 4, and it works its way up. Now, when it crosses the x-axis, it crosses the x-axis at basically the ordered pair where the y-intercept for the e to the x, 0, 1, interchange places. This pair ordered pair now would be 1, 0. Okay? So if anybody asks you what's ln of 1, it's always going to be 0, and it's because if you can remember this picture, you'll be okay. All right, so this is now 8 plus 5 times 0, which is 8. Okay, so we find our M10, we have our Y1. We can write this now in point slope form. Y minus Y1 equals M10 times X minus X1. Y minus 8 equals 5 times X minus 1. And now you just convert this to be in slope intercept form. Distribute the 5, so it's 5x minus 5. Then you add 8 to both sides. 8s are gone. You get y equals 5x plus 3. And that will be your solution. All right, pretty good.